if we think about the different factors that influence the size of a population, we can break it down into really four basic processes that lead to population changes. And so the most obvious ones are birth rates, increases to the population, and death rates, mortality and natality. Death rates decrease the population. Those two things have a major impact on the size of a population. If birth rates are higher than death rates, we have a growing population. If it's reversed, we have a declining population. And if they're equal, we have a stable population. But there's other factors as well. We could also consider immigration, the movement of individuals into a population from another population, and emigration, losses due to people moving or organisms moving out of a population. And again, those two are in opposition. Okay? If immigration and emigration are equal, that's a stable population. So we can consider those four factors, and then we can calculate growth rates of the population. So one thing to mention is that oftentimes birth rates and death rates and emigration are quantified by demographers per 1,000. Okay, so for example, a crude birth rate of a given population might be 25 births per 1,000. And so we'll often see that notation. So if we're interested in the growth rate of a given population, we can calculate it by taking the crude birth rate, the births per 1,000 individuals, plus the number of individuals immigrating into a population per 1,000. Subtract from that the crude death rate and the individuals leaving the population. That will give us a number. And then if we divide that number by 10, it gives us a percent growth rate. Because again, these are typically given per 1,000. So if we divide by 10, we get per 100, or a percentage. We could also rearrange things a little bit, and we can have births minus deaths, plus immigration minus emigration, again divided by 10, will give us a growth rate. So all sorts of factors come into play when we're thinking about the population dynamics of a given group, of a given part of a country, etc. And so factors include obviously birth rate, death rate, infant mortality, access to family planning, nutrition, education, age of marriage. These are all factors that influence population growth, and they vary from place to place. If we're thinking about human populations, all of these factors come into play, and they're unique to given areas, right? All of these factors are important. Things like healthcare, cultural attitudes towards family size, religious prohibitions on things like contraception, for example, social norms, availability of contraception. All of these factors influence the growth of human population size. So humans have asked for a long time, well, what size population can the Earth support? What's the carrying capacity of the Earth for humans? Someone you probably have heard of is Thomas Malthus, who in the late 18th century wrote an essay on the principles of population. And what Malthus thought is that population will grow, and eventually, if it outstrips available resources, then there will be some crisis, a Malthusian catastrophe that will reduce the population in size, because there's not enough resources beyond that to support the population. But what we have seen when we think about this is that innovation, technology, culture has altered many different factors related to population size or resource availability. And so what we see are these little bumps where we have a growing population, but then some sort of technology arises that allows for the population to expand even further. The mechanization, the Iron Age, use of water, and so forth was the first wave. And then steam power, mechanical advantages, railroads, etc. Again, was another wave. Electricity, cars, synthetic chemicals, TV, computers, aviation, etc. So every time we think maybe we've been reaching maximum population size, some technological innovation has allowed us to grow actually beyond that. So we haven't actually seen some of these Malthusian catastrophes as Malthus predicted. Now we do see them localized in given areas. We may have a famine or lack of water or disease outbreak that limits population size in given areas. But if we're thinking about the earth as a whole and humans, then we have not seen that. And when we think about population growth, we consider two types of factors that are may come into play: density-dependent factors and density-independent factors. And they're just what they sound like. Density-dependent factors are factors that depend on the population size and density. Disease are transmitted more easily when people are living in dense settlements. Clean air, food, water, those factors are impacted by population density. And we can see here an example of that. This shows COVID deaths as related to population density. In areas where we had higher population densities, then we saw higher levels of death due to COVID. There are also density independent factors, things that don't have any connection to the density of populations. Oftentimes these are things like natural disasters, storms, fires, heat waves, droughts. These can certainly affect population size, but they're not dependent on the number of individuals living in a given area. One more mathematical tool that we can use when we are trying to predict a future population is something called the rule of 70. This is a rule you'll have to use in class and on the AP exam. And the rule of 70 states, and it doesn't just apply to human population, it applies to any growth rate. You may have heard about it in terms of finance or compounding interest, things like that. But the rule of 70 is if you take the number 70 and divide it by the growth rate, in this case we're talking about human population growth rate, that will give you an approximation of how long it will take that population to double. So for example, if we have a population that has a 0.7% growth rate, if we take 70, divide it by 0.7, we get 100. That means at a 0.7 growth rate, this population should double in about 100 years. If we do some other examples, 70 divided by 1 is 70. A 1% growth rate doubles in 70 years. And we can see some other calculations here. So if you're ever being asked about what the population of something will be in the future, you're going to use this rule of 70 to estimate that population size in the future, because you can calculate the doubling rate.